Hello, everybody, and welcome to Regenerative Living's Stop Erosion webinar with Jeffrey Adams and Neil Bertrando. It's such a pleasure to have everybody here today. And if you're watching live, pleasure to have you live. And if you're watching after the fact, pleasure to have you after the fact. Today, we're going to have an incredible conversation about low-tech erosion controls, which is using simple shovel-ready approaches to be able to slow and pacify water, to spread it out, and to really address erosion where it begins. For those of you that haven't experienced one of these webinars before, we're going to do about a 45-minute presentation. If you have questions during that time, you can put questions down in the Q&A area. If you have any comments as you're going through or things that you enjoy, you can always put it into the chat, and the chat is open so you can talk to anybody and reply to anybody. It's a great thing about the features here on the Zoom webinar. You do have that ability on the chat, and it tends to go pretty quick. So don't worry if you don't answer to everybody or vice versa. That's all right. Then we're going to have a short conversation about the Low Tech Erosion Control self-paced course. And then we're going to go into Q&A. And for everybody that sticks to the end, during the Q&A, there's going to be 3 people who are going to win access to the Low Tech Erosion Control self-paced course. So if you stick right to the end, we're going to be pulling 3 lucky winners from that conversation. To start off, my name is Jav Bernakovich. I own and operate regenerativeliving.online, an online educational platform built to create conversations around practical skills to live on the planet as if we intend to stay. Years ago, I was noticing that there was a lot of isms and ologies and a lot of people becoming pretty forcibly entrenched within those isms and ologies. And I just wanted to host conversations about practical skills that people could use today. Didn't matter what the situation was, didn't matter what beliefs you held or what ologies you were curious about, but if you had the certain context for that problem, you could apply that problem well. And so reached out to Neil, who I've known for a number of years, and has just been an incredible designer and implementer, nurseryman, food producer, and just all around A+ when it comes to land design and conversations, and taught me a lot about design and conversations. Then when I reached out to Neil, he then said, well, I think we've got to bring Jeff into this, learned about Jeff's incredible work with TerraSophia and the incredible book the 2 of these gentlemen have put together, and I'm sure they'll talk about it as well. So with that, I think I'm just going to let us fly with the presentation because we've got a fair amount of people who are keen on this. If you've just come in, feel free to let us know where you're coming in from on the chat. And I'll take it away, gents. I can't say enough good things about the 2 of you and your work. Thanks so much for taking the time out to both create the course and also to do the webinar today. I know there's a lot of people who are keen to be here.
Awesome. Thank you, Javin. And thanks everybody for joining us. Really excited to share some of our experience and passion about erosion control and watershed restoration. My name is Jeff Adams. I own TerraSophia, which is a watershed restoration and landscape contracting company based in Moab, Utah. And just really passionate about all things water. I've been running this business for coming on 20 years now. So I've just been really excited to kind of see the different angles to take and all the different scenarios and contexts that we can put these principles and patterns into practice. So looking forward to sharing with y'all and coming up here in the webinar.
Thanks everyone for showing up. I'm excited to share with you as well. Thanks, Javin, for the great introduction. My name's Neil Bertrando. I live in Reno, Nevada with my family, and I own and operate a single-person business called RT Permaculture, which is an umbrella for my various actions in consulting, design, education, horticulture, all the different things that I do. And my passions are soil, plants, and people. And so I'm going to get us going right into the slideshow here and show you more about low tech erosion control. All right, can everyone see that?
Looks good, Neil.
Great. So here you can see both Jeff and I and our pretty faces in front of a beautiful landscape up in the mountains of northern New Mexico near the Colorado border. This is actually where Jeff and I met and where we first practiced low-tech erosion control and slope wetland restoration together. One of the great things about low-tech erosion control is that often many hands make light work, and lots of it can be done by hand with a group of people, and it can be a really joyous collaborative experience. So here you can see a group of us working together at a workshop hosted by the Quivira Coalition, building some rock mulch rundowns and log mat grade controls on a stream that's coming out of a slope wetland. So low tech erosion control, what is it? Basically, it's using primarily natural materials, mostly plant-based materials like logs and sticks, as well as rocks, and then also things like seeds and other propagules to grow vegetation, and using those natural materials to create erosion control structures and heal watersheds. And it's a broad toolkit, so there's a lot of different options that you can use of scalable, shovel-ready techniques. And I think one of the important things to remember whenever you're practicing erosion control, you're slowing down the movement of sediment. But in order to do that, you're also harvesting water. So all erosion control structures have some water harvesting capacity, and often harvesting and storing water in the soil is actually one of the primary functions of practicing low-tech erosion control. I think it's important to keep in mind that the function of rivers and waterways, and even runoff, is really to move mountains to the ocean. And so there is going to be some amount of sediment movement as part of the natural processes. But when we start to get excessive sediment movement, it starts to become a pollutant and starts to clog waterways, and or we start to dehydrate and drain landscapes by cutting into them with gullies. We'll cover that a little bit more in a bit. So both Jeff and I came to low-tech erosion control from slightly different pathways, but they converged on the work of Bill Zeedyke through the Quivira Coalition. And there's a lot of different practices and influences on us for low-tech erosion control. And the real fundamental foundational one is inspiration from indigenous peoples that have been managing watersheds for millennia. And in the upper left corner of the screen, you can see some historic rock work and retention structures that were built by indigenous peoples in the drylands of the Southwest United States. And so that sort of intuitive relationship with nature and water is also supplemented by the scientific basis of understanding how water works in the landscape and moves through the landscape, as well as how rivers and streams function. And so Bill Zeedyke is a phenomenal watershed restoration practitioner. He was a wildlife biologist for years with the U.S. Forest Service, and also a student of Luna Leopold and David Rosgen, who developed some of the modern concept of fluvial geomorphology. So that informs a lot of our understanding of streams. And then Jeff and I had the great opportunity also to work with Craig Sponholtz of Watershed Artisans, as well as Steve Carson, who were both students of Bill Zeedyke and got mentorship through them and through the Quivira Coalition doing watershed restoration at high elevation slope wetlands. And then there's also, folks like David Bainbridge, who have developed some really sophisticated and simple techniques for desert and dryland restoration, such as, vertical mulching and wick irrigation and other sorts of situations where you can get vegetation established in very dry landscapes. And currently there's a great movement going on, which is being really pushed by Utah State University in low-tech process-based restoration, looking at how, in particular, beavers can become ecosystem engineers and utilizing beaver dam analogs, or BDAs, to really help influence the restoration of waterways. And finally, I want to say another shout out to Quivira Coalition and the amazing work they've done to promote both Bill Zeedyke as well as many other low-tech erosion practitioners, and also putting together many technical manuals that are available for free on the internet that are specific to low-tech erosion control. So what we have in the low-tech erosion control toolbox is a set of many techniques that integrate with watershed restoration and property management. So they're not the only tools in the overall toolkit, but they in themselves represent a very distinct and effective toolkit that should be accessible to anybody that has land to work with. because you're primarily using natural materials that you would find on the landscape. And applying low-tech erosion control can create improvements in drought resilience in your landscape. It can improve water quality and water quantity. It can create wildlife habitat. It has opportunity to create post-wildfire stabilization, stormwater management, as well as improve the vegetation health and vigor in the landscape. And that's really important because the vegetation is really what provides the long-term stability and erosion control in the landscape. And healthy vegetation provides so many other benefits, including the wildlife habitat as well. And then finally, it can help you with property protection. If you have things like erosion moving towards your property or through your property and making prime land lower quality. So one of the tools that we use in the low-tech erosion control toolkit is the stream evolution triangle. And what this is basically 3 legs of a stool, and it's important to consider all 3 legs. So this is a tool for understanding and assessing a site, making sure that you look at the geology, the biology, and the hydrology, all 3 of those things, and you're not ignoring one because they play a fundamental role in then how you would be implementing your low-tech erosion control structures. And then those low-tech erosion control structures should also address the geology, biology, and hydrology of the site. And geology particularly refers to how structurally stable the soil and bedrock materials are on the site. So are you dealing with rock, or like in this example here, between biology and geology, we're dealing with historic wetland sediments, which are just organic materials, and they're very, very erodible sediments. And so they fall apart very easily under the force of water unless they have, very solid vegetation on them. But in biology, we're looking at what types of vegetation, how do we stimulate the biology, and how does the biology inform if we're in a wet area or a drier area. And we're always trying to support the biology because it is the long-term stabilizing factor. And then finally, in hydrology, what is the stream power? What sort of force of water are we dealing with? How deep and how wide? How often does it actually flow through the site? When are the peak flows? All of those things are important to keep in mind. And so the stream evolution triangle provides a guide for us to organize our thoughts and also make sure that we come back and reflect on and don't forget some portion that's a critical piece of the puzzle. So I always start my erosion control with looking at the soil cover, and because soil cover, whether it's living vegetation or mulch or some form of rock that's larger than a soil particle, it stops the initial point of erosion, which happens when the raindrop hits the landscape. And so any soil cover will dramatically reduce erosion on the site, and that means water will be infiltrating into the site and providing water storage for growing vegetation. And in particular, there's been studies where they look at percentages of soil cover, and between 40 and 60% of soil cover reduces erosion to almost nothing. So if you can just get 40% soil cover in your landscape, you're going to have a dramatic effect on improving the water cycle, reducing erosion, retaining water to grow vegetation, and then that tends to spiral upward and create better and better outcomes. So in parallel to the stream evolution triangle, we also have the soil erosion triangle, and this triangle was developed by Brad Lancaster. And it's important because an increase in any point on the triangle, water depth, water volume, or water speed, will cause an increase in erosion. And so what we're looking to do is any intervention that spreads, slows, or sinks the water by basically decreasing any one of these 3 factors, by decreasing the water volume, by decreasing the water depth, or by decreasing the water speed. And so that gives you a broad array of options to select from, but really just 3 guiding factors: decrease the water speed, decrease the water depth, or decrease the water volume. This model, the stages of gully development, was developed by Craig Sponholtz of Watershed Artisans, and I find that it's a very powerful tool for understanding where we are in the landscape and what the opportunities for recovery are, and also how easy it's going to be to do erosion control work. So if you look at the very beginning stage of gully development, it's just sheet erosion, and you still have plants and litter layer and topsoil. You know, you have a very high potential for landscape recovery for a very small amount of work. This little rill that's starting to form and pedestal formation in the next kind of 2 stages means that you're starting to erode through the topsoil and vegetation layers. You're drying out, you're getting less vegetation, you're getting more exposed bare soil, and you're getting deeper cuts in the landscape that are more difficult to control and stop erosion and slow down the flow of water and spread it out. And then as you go further to rill expansion and gully formation, the force of water has dug down and eroded through the topsoil and even some of the fine subsoil, and you're getting into coarse subsoil and bedrock, which don't support vegetation very well. You also start to get deeper into the landscape, and it gets harder to spread water out and slow it down, and it's being concentrated and speeding up and has more force, so you have to build bigger structures for a lower return on your investment in erosion control and water harvesting. And so what we always recommend is to try and focus your actions on locations of the landscape that are performing relatively well and have a high potential for increasing their performance for a low investment and a low risk for the work that you're doing. So if you can work on in these stages 1, 2, and 3, sheet erosion, pedestal formation, or rill formation in the stages of gully development, you're going to have a lot better return on investment for your work, and you have the opportunity to learn in a relatively low risk environment. So that's where we recommend focusing your work. Sometimes the places that look worst in the landscape are the ones that we want to work on to try and repair, and they're the ones that we could spend a lot of money and time working on and not get very much back. And it can be counterintuitive. People always want to show you, oh, I have this big problem, this big erosion gully. What are we going to do to fix this? And sometimes it's like, well, actually, can you take me to show me the places on your land that are working well? And we can either use those as models to mimic and try to bring other areas of land in function up to meet that. But also we can look at things that we can do to protect those highly functional portions of the landscape to make sure that we don't lose the things that are already producing really well, and even enhance those rather than just trying to fix some big scar in the landscape. And with that, I'm going to hand it off to Jeff.
Awesome. Thank you, Neil. Great overview of some of the key concepts we're thinking about and looking to include in our thinking. And so now probably a lot of everybody's wondering, so what does low tech erosion control actually look like? And in classic ecology and permaculture, it depends. So it's really going to be honing in on what's your specific context. Are you working in a high elevation wet meadow? Are you working in an arid or semi-arid area? Are you working in a channel? Are you dealing mostly with sheet flow? So that's why it's really important to understand some of those processes that Neil went over, as well as some of the overall patterns that guide the application of the toolbox, because I really want to encourage people to take inspiration from what we show you and talk about, and then innovate and adapt to make it work for your situation. And so we're always thinking about how do we fit these techniques to site conditions. And so we're often hybridizing and innovating on the kind of standard techniques. So in this case, this was a gully that was forming as a result of a pathway. So trails and roads are often major causes of degradation in watersheds because they intercept what might be sheet flow, and they start to concentrate it and run it down that path, down that road. So here we were starting to get exposed rocks, having vegetation falling into the channel. And so we came up with a solution that included using logs and brush from an invasive species removal project, along with locally available river cobble and what we often call dirty chips. So we'll do a lot of projects where we'll mix wood chips with mineral earth about 50-50 and use that to pack in amongst the brush and logs. And once it gets moist. It holds water really well. It turns into a good growing substrate, and you can fit it to any shape you really want. And so this picture on the right, you're seeing essentially a log and rock step pool system. So if you go into high elevation mountains, often in very steep terrain, you'll kind of get these cascading of sort of waterfall pool that helps to dissipate energy of that water moving down those steeper grade changes. And then in the kind of upper center of the picture, that's a media luna. So that's a structure that's designed to intercept the channelized flow, spread it out as much as we can within the valley width of our specific context. And then as the water overflows, it's reconcentrating to go down this steep grade change. And so we did this project in 2020. A couple years later, it got put to the test, and it was really cool to see how well it worked. So in this picture, you can see a lot of the vegetation flattened out from that running water over it. You can see some sediment deposition upstream of the rock structure, as well as these log and rock step pools catching and holding sediment, and these little scour pools forming. And those, you can still see the moisture being held in the sand, because that pattern in the landscape helps to not only dissipate energy, but it also catches sediment and creates micro pools so that more of that water can stick around a little bit longer and soak back into the ground to either be available for local vegetation, local soil moisture, or perhaps if your hydrogeology is conducive to it, it may help to recharge shallow aquifers as well. So we're really always looking at what's the shape of the land I'm working with, and how do I fit my techniques into the land and the context I'm working with. And so we've kind of come up with these, we call them anatomy of common LTEC structures. And these are the things we're thinking about in each application. And we're looking at the flow paths. So where's water coming from? Is it sheet flow? Is it concentrated into rills? What's the cross-sectional area of that flow path? How wide and how deep? So that kind of goes back to that triangle that Neil was talking about. So if we can work with the depth of water and get the same volume of water to flow over a broader area, we're going to decrease the energy and the erosive capacity of that flowing water, and we're going to increase the potential for some portion of that water to soak in. We're always looking at critical elevations. We want to make sure that we're working with water and helping guide it to go where we want the water to go, rather than letting the water choose its own path, because water is brutally honest. It will always find the low point. And if we don't design for that low point and design with those elevations in mind, we could have water blowing out our structure in a place that we don't want, or we could inadvertently back water up and pool it up against a tree or a building or something where we don't want that water. So always pay attention to the elevations. And then we want to make sure that these techniques that we put in, that we're creating stable shapes. So that's that angle of repose, the side slopes. We want to either lay the soil back to a shape that it can be relatively stable on its own, or we want to look at reinforcing it with some sort of armoring. And that's, so these, I should back up a second and say, we broke these into individual bullet points for the ease of kind of making sure our mind jumps in kind of like a checklist to think through all these. But most, if not all of them, they're all interconnected. So as we work with one piece of the anatomy, we're invariably also working with some of these other bullets on the anatomy of these structures. So then the wetted area, we want to think of like, what are we inundating? If we catch water, if we pool it up, if we put in a one rock dam and back water up, how's that water going to influence in the landscape? And so if you're in a narrow, tight gully, like the later stages of gully development, and you do a structure, your wetted area is going to likely be relatively small. Whereas if you are doing a erosion control intervention in a broader valley or a sheet flow instance where you can spread the water into a greater area, you have the potential to create a larger wetted area with your treatments. We always want to think of overflow, and so this is both thinking about wildland situations where we're kind of more in a gully or a creek, as well as our residential or property-based water harvesting earthworks. We always want to plan for that overflow and use that overflow as a resource. And we're often doing these structures in treatment trains. Edges and transitions, that's going to be where does your structure end and integrate into the natural landscape. And those are really key areas to make sure that they're solid and that we have good edges and good smooth transitions, because those are often weak points that may end up being points of failure if care isn't taken to integrate your structures adequately into the surrounding landscape. We want to think about our material size and type. What materials do you have available? What sizes do you need to withstand the flows that you're working with and to achieve the elevations that you're trying to get? And so we can often take cues from nature. And if you see a lot of really large boulders that have just been come down the mountain deposited, then you know you need really big material to work in that particular context. So we can kind of learn from what we see and read in the landscape to help inform our design decisions. Armoring, I hit on that a little bit. That's essentially some material to cover the bare soil to provide additional resistance to flowing water, the impacts of raindrops, as well as armoring against different ungulates and animals that might interact with our structures to make sure that we're not having hoof prints kind of undermining the edges or something to that extent. Then tightness and space filling, we want to build our structures so that water flows over them, not piping through them. That can be another common point of failure, is that water hits, say your rocks are stacked too loosely, and the water just goes through and under them and essentially renders the structure not really there. It still adds some roughness, but it's not getting the function if we don't have that tightness of our materials. And then treatment trains, that's generally the idea that one structure flows into the other, flows into the other, flows into the other throughout the course of the area that you're treating or the phase of the treatment that you're able to do, because lots of this work ends up being done in phases. It's very much not a one and done type of approach. So now I want to jump into a couple case studies just to sort of highlight a couple examples of what this looks like in action. This is a residence here in Moab that was subject to some pretty severe flooding and sediment deposition, and that was caused for a couple reasons. One, the location of the house was on an old alluvial fan, so that's a geomorphic feature where water wants to braid and spread out. And another is that up gradient of this is a detention pond that ended up blowing out because it wasn't properly built and maintained. And so all these blue lines are where the water flowed during these really big 100-year storm events. And the orange is the sediment deposition, where essentially the house acted as a dam that pooled up water and sediment on the upstream side of the building and ended up depositing about a foot of sediment right up against the house. And so we had to dig it out and come up with a solution to protect this property. And so here's a concept of what we did, where quite literally we parted the waters. So we redirected the flow paths, paying close attention to the cross-sectional areas so that we didn't want to constrict the flow and increase the flow pressure. We wanted to actually broaden the flow and slow it. And so we remade three flow paths that kind of brought that water around the building and then had a redundant series of berms and rock work to intercept that water, slow it down, catch sediment, and start to re-veg this site in multiple locations. And so this is the concept schematic of how we were able to work with those flow paths and integrate some of the flows that we didn't want going right at the house and put them back into some of the natural flow areas that were also present on the property and on the adjacent property. And so here's an aerial image of what that site looked like post-construction. And so all of the light tan here, that's all these dirty chip, these wood chip and mineral earth berms that also have logs and rock reinforcement. And then we have this series along the right side, the edge of the property, of these one rock dams. And so that's the main outflow of the up gradient detention pond. And just really, it's fairly steep. So we wanted to intercept that flow as frequently as possible. Each of them is shaped so there's some pooling capacity, soak that water in, have it there to support some of this native vegetation and protect this property from future flood events. Here's a view of before, kind of looking from the top of the property down gradient, and you can just see, like, you can see the fence line. So it's actually a multi-neighbor issue where the runoff from neighboring properties ends up finding a new low point, a weak spot, and crossing the fence line and coming on to this client's property and then heading straight for the house. And so we're able to work with that and stop some of those cutovers and accentuate the flow path down the property line where it can be a benefit to the vegetation and protect the property from any future damage. This is that same area, but looking up gradient, you can see some of the houses that are contributing the stormwater runoff issues. And then this, where my cursor is, that big rock apron, that's the overflow spillway of the detention pond, which is really just kind of directly up gradient of this house. And so for me, as both a watershed restoration practitioner and a landscaper, I'm always trying to get multifunctions and integrate aesthetics and places for people to be in the landscape. So especially in this residential setting, we made some of the rock work into seats, and we tried to include an aesthetic component as well. Another view of the same property, essentially their whole driveway got covered in sediment. Here's a nice, beautiful alluvial fan, which is something that we would want in a natural setting, but that we don't want on somebody's driveway and coming up against their house. And so with that, we rock armored the flow path, and we created a new low area down along the edge of the driveway so that the water, instead of coming and fanning out on across the driveway, has some space to kind of cut across the corner of the driveway. And then there's a whole nother section that takes it around it and down the edge. And as we were building this, it was pretty steep, and we came up with that we could also make these rocks into some steps. So this rock rundown and the berm that it ties into are now a path that goes along roughly the perimeter of the property. So it greatly increased the site access as well, where it used to be sort of that there wasn't really any clear spot for people to be. Now we got that additional benefit as well. Switching it up, a very different scale, similar pattern, some similar issues. At this site, we were dealing with a lot of sheet flow runoff coming off of this driveway, this gravel area, that then essentially when it got to the property line, it starts going down the steep gradient, and it was eroding the hillside and depositing a bunch of sediment onto the neighbor's property, which they weren't very happy about. And at this site, they already had this roof catchment system in place. And at the time that we started the project, it just overflowed onto the gravel and wasn't really being used beneficially, and was actually contributing to some of the erosion that was crossing onto the neighbor's site. So with this, we designed to accommodate those multiple flow paths. So we wanted to accommodate the overflow coming off the roof and out of the cistern, and we wanted to accommodate the sheet flow runoff coming off of the gravel driveway. And so we're able to do that by keeping the edge of our treatment flush with the driveway, so that that water can just sheet off and into the basins. And then we created a series of basins with these one rock dams or rock spillways to help to catch and hold the water coming from the tank as well as the gravel driveway. All of the soil that we dug to lower the elevations here and create the shape to hold the water was used to create a berm along the property line, so that it held all of the water from this property on this property and soaked most of it into the landscape to support some native plantings that we put in. And then it's the final overflow, it then crosses the driveway here in a shallow rolling dip, just a kind of little water bar, and goes into an adjacent field. So now we've turned what was runoff from one property onto another into a resource for this property and kept all that water onto this site. And here's just another close-up picture where you can see the shaping of those rock structures, and that shape is really key. And that comes back to those edges, where if you look closely, you can see that the edges are higher so that there's a clear flow path for the water down the center, and those edges are tied up into the banks to minimize any chance of that water end cutting and undermining this structure. One of my favorite things about the work I do is this visual inspection, is being able to go out after a rain event and see what happened, see what worked, see what didn't work, see where we might want to do some additional treatments. It's always easier to fix something if you catch it right away than let it turn into a problem. In this particular case, this rock structure caught sediment, filled in, and worked great, and now it needs another lift, means it needs another bump up, another layer, so that it's ready to catch more sediment in the next rain event. And so that again comes back to that iterative and adaptive aspect of these types of techniques, is we put them in, we watch how it works, and we adjust and we add to them, and we manage and we steward these types of structures over time if we're able to within the project budget. It's easier when it's on your own property than it for a client perhaps, but that's the goal. And one of the great ways that we like to monitor these and just kind of see their effectiveness, see what's happening, is through repeat photography. It's a really simple way to just take photos from the same location, so we can do before, after, and then come back at some interval, whether that's yearly, whether that's after a couple years after a rain event, and see what's happening, see how the vegetation's changing, see where we've caught sediment, and we can start to document and show, hey, look, this stuff does work. And so this was a really fun project here down in New Mexico. And I think with that, I will turn it back over to you, Neil.
All right, thanks, Jeff. So in order to kind of organize the complex reading of the landscape and then assessing, designing, building, and maintaining these projects, we've created this iterative project process. And it's foundationally based on the adaptive management cycle with the kind of flow of a project, an LTEC project integrated into it. And so each phase has many steps. For example, in the assessment phase, you're going to do some remote assessment. You're also going to do some site visit assessment, and then you're going to analyze and interpret that information to inform the next phase, the phase of design, for example. And not all projects flow in a straight line through this process. Sometimes you'll go from build back to design, and you'll be doing kind of both of them at the same time in the field because you see something new as you're starting your build, and you adapt your design slightly, like Jeff was describing with integrating the stairs into the rock mulch rundown on his residential project. And then, so this process basically provides you with a series of checklists and stages that you're going to be thinking about flowing through as you go through your LTEC project. And we explain this in detail, each of these in our course. So during the assessment phase, one of the things that's really important is to understand where you are in the landscape, what the topography is, and what your position is in the landscape, because water changes its kind of flow paths and properties a bit as you move through the landscape. And there's different opportunities that occur at different locations in the landscape. And so this graphic was developed by Craig Sponholtz and Avery Anderson Sponholtz, and it shows you the basic areas in the landscape where you might be considering low-tech erosion control, from the top of the watershed to the top of the hill down to the valley bottom before you get into a major stream or river. And there's the collection zone, which is a great area to do watershed restoration. And it's primarily sheet flow with low quantities of water concentrated. And then it's where the water starts to collect up and then turn into channelized flow at the transition. And so there's different types of structures you might use here, like rock mulch rundowns or media lunas tips down to transition into the transport zone. And the transport zone is the steep section of the hill, and it's really fairly steep and erosive. It's high energy, high risk, with low potential for soaking water into the landscape because of the steepness, and often the flow of water is confined to a fairly narrow channel. And then as soon as you exit the transport zone, at the toe of the slope where the land starts to flatten out again, you get into alluvial fans and channelized flow zones where you can use all sorts of techniques like one rock dams and Zuni bowls and media lunas and brush mineral or chip and mineral berms to slow down the water. And this is an area of high opportunity. And then finally, when it really flattens out, you get the deposition zone, where you get, large alluvial fans and braided channels and opportunities to soak in a lot of water and settle out a lot of sediment before it gets into, a river or something like that, where it becomes a pollutant. And media lunas and contour rock mulch and other sorts of features like that are very effective in the deposition zone for storing lots of water and rehydrating a lot of vegetation. And then what we do with our remote assessment is we try to look at the landscape using aerial photography, things like Google Earth, understanding the watershed boundaries and sizes to get an idea about how much water might be flowing through a particular site or even a particular flow path on a site. And then optimally, we get a fairly detailed topographic map through some sort of survey or through online data that's available. And we mark out the different ridges and the different flow paths or valley bottoms to understand where the water is coming from and what each of the sub watersheds are on the site to identify opportunities. And when you can use a map like this to then generate something like a slope map that shows you the different percentages of slope or degrees of slope, basically the steepness of the landscape. And I really like to focus on areas between 0 and 8% and optimally between 0 and 4% in slope, because those are areas where a small intervention or a fairly low rock mulch on contour or stone bund or even earth berm or something like that can hold a lot of water and rehydrate a large area of land with a good vegetative response. And they're also the areas that are easiest to get to and easiest to work and lowest risk. So identifying those areas using a map really narrows down and identifies where on the site we could focus our work for the greatest return for the least amount of effort involved. So we also cover the common functions of low-tech erosion control treatments in our course. And Jeff and I went through and basically created a bullet point list that covers these different common functions. And similar to the other lists and much of this work, most of the structures are doing more than one function. So they're not isolated in the fact that they're stabilizing an area. They're doing multiple things. But in order to wrap our heads around the different things that they can do, it's good to identify them as individual units. So we're always looking to create stability in the landscape. And most often in erosion control, we're stabilizing an area. So we're stabilizing a head cut, which is basically the cut in the landscape where water pours over into a rill or gully, and that erosion continues to move up the landscape and unzip and dehydrate the landscape. So they're very important pieces of the puzzle to stabilize. We might be stabilizing a low energy channel or a flow path with something like a grade control, or stabilizing a bank with using different bank stability techniques. So this photo here is actually showing you a good example of a low energy channel or flow path being stabilized by a one rock dam across the channel, a grade control. We're looking to stabilize slopes if you have steep slopes, and a lot of times that will be using vegetation. We're looking to stabilize soils or vegetation. You want to not have vegetation falling over or sloughing off into gullies and things like that. And also we're looking to deter ungulates, and that's in things like cows or other livestock, and also elk that can get into your structures and really start to pug up, or even get into the landscape and pug up the landscape and start trailing or other forms of erosion in the landscape. Then we also are commonly looking to alter flow paths. So by altering flow paths, we're going to be maybe redirecting the water to a historic floodplain. We want to slow and infiltrate water. We're looking to spread out the flows over a wider area sometimes, so that we return channelized flow to sheet flow. Sometimes we actually want to concentrate the flows and force the water into a certain area. And then often we're looking at splitting the flows to maintain enough moisture in the current flow path of the water to support vegetation and maintain integrity, but also to take some of the pressure off of that flow path and redirect some of the water out into the broader landscape. We're looking to manage sediment flow, and especially in the drier landscapes of the world, whenever water is moving, some sediment is moving with it. And so these structures are often designed to both retain sediment and collect it and store it in the landscape and fill up the structure, and also many times to manage the flow of sediment, especially as you get to stream and creek type of situations, where you want to balance that flow of sediment with the flow of water down the system and store it in appropriate locations, like perhaps a point bar. And then finally, we're looking to grow more desired vegetation. And basically all the structures that we build are looking to grow more desired vegetation, because vegetation is the final ultimate outcome that really has that biological regenerative resilience and capacity to store water and control erosion in the long term in the landscape. And then typically all of our structures are implemented in what Jeff and I like to call treatment trains, so that there's more than one structure that's integrated into a series to manage the flow of water and sediment through a site or through a project area. And they perform multiple functions. So we'll look at some examples of these things. So here's an example of what Jeff will often call an upland beaver dam. It's a brush mineral structure where you have a whole lot of long branches. I think these ones were tamarisk or Russian olive taken from an invasive species removal project. And then you have the mineral earth, which is basically soil or sand, silt and clay, minerals, as opposed to topsoil with organic material. And that's packed in between all of these branches, as well as packed in with the chips, and tightly packed in so that there's not air spaces and vegetation can grow in there. And it really creates kind of a stabilizing feature. And so this is able to stabilize the slope and create some little terraces that also store water and support the vegetation that exists there. Here's an example of altering flow paths. And so the original flow path is going down to the right, kind of in the direction of the mini excavator there, flowing over the top of this log mat structure. You can see that we built it so the water flows over the top, as Jeff mentioned, and it's able to transition down into this vegetated channel. And then also we set the elevation just high enough so that 50% or so of the water goes down the existing channel, and about 50% flows out the side and reaccesses this historic floodplain, which was a wetland. And we could tell that from the soils, and it has historic wetland soils that don't develop in uplands. And so it's rehydrating this broad swath of valley bottom where normally the water would be concentrated in this little channel and just hydrate the vegetation in this one small area. And so it's spreading back out to a historic area the water accessed, as well as maintaining the channel and the primary flow of water. And here's a great example of the treatment train. This is a photo similar to the first photo in the landscape from that same workshop, and a little bit further, first photo in the presentation, a little bit further down. And you can see that we have multiple structures. Up here where the people are working, we're doing rock mulch rundowns and some log step downs here at what is basically a large head cut moving up the alluvial fan slope wetland. And then down here in the channel, we've created grade control structures, a log mat with rock armoring around the edges to stabilize it, and then another log mat. So the water, flows down these stabilized features, the rock mulch rundowns and step downs, and enters this channel. And so we've slowed down the water before it enters the channel and stabilized the head cut, and then allowed the water to be again slowed and sediment and water to be captured by creating these grade controls in multiple steps as the water moves down the incised channel area. And the one interesting feature about these log mats or one rock dams or those sorts of grade control features is that you put them at the crossover in the channel. So you can see there's a turn here, and then we're going straight, and the crossover is the point where the direction of flow starts to change and enters the next turn. So that's a straight part in the channel, and that's fairly stable. And then the turn happens, and then the next straight part in the channel, we put the next log mat, and that continues down the stream in a consistent pattern. So that's an example of a treatment train. And as I emphasized at the very beginning, these projects can be really great to do in collaboration as workshops with large groups of people. To many hands make light work. You can see the chain of people moving rocks from the pickup down into the gully and armoring the base of this log mat structure. And really, it helps to reach out and partner with either organizations or other people doing this work, attend workshops, and work together with a larger group of people. And particularly in larger landscapes, you aren't going to have a choice. You're going to have to collaborate with landowners or land managers. But we really encourage this sense of collaboration and building community, because water is a basic necessity, and it's part of the commons. And if we can steward it as a community and respect it as a community, it also helps to build our relationships with each other and the larger landscape. And so we encourage everyone to really embrace the spirit of collaboration as part of their low-tech erosion control efforts. And we encourage you to go out there and do something. Start small in a low-risk area, put some rocks in the landscape, or interrupt a flow path of water, and learn from it, and then build off of those experiences. All right, thank you very much.
Brilliant. Thank you so much, Neil. Thank you so much, Jeff. Thank you so much for taking the time to share your experience. And it's incredible because over the last couple of years, I've watched you gentlemen and all of your case studies and conversations, and just the simplicity at which people can pick this up comes through every single time. It's really about starting small, like you were talking about, Neil, and like what inspired Jeff initially, like starting in those really small rivulets, starting that conversation and being so present to it. So just a huge thanks to both of you for the work you do, and also for being on the webinar today and sharing that. I know the 56 odd folks who are here live really appreciate it. And there's been a lot of folks saying so in the chat. So thank you very much, gents. So for everybody who has questions, feel free to put it into the question and answer document there, or pardon me, the question and answer section in Zoom. I'm going to quickly run folks through a conversation that I think will be important for everybody to be present to. So when we take a look at the conversation of erosion, it's happening everywhere, because as we take a look and work through and are in modern society, and Brad Lancaster said it best, is really in the drain age. What we need to move into is the retain age. We need to move into an age where we slow sink water in an easy to understand way. And that's what Neil and Jeff have done so remarkably well, is that they've really taken this conversation of how do we do this in a smart, intelligent way. And when partnering with these two fine gentlemen, it's been phenomenal to be able to bring this conversation to the forefront. So, question for everybody: do you want to stop erosion? Is this something that feels important to you? Is this something that you want to incorporate into your work, your life? Do you want to have tools that individuals have already worked through the problems to be able to apply to your landscape? And with that, do you want to learn how to design and implement those low-tech erosion controls? Because this is where you have two options. You have the option of trial and error, do it yourself, figure it out, and that works. There's no problem with that. Most of us have done that within our work. But we all learn from mistakes. They just don't have to be our own. And this is where the simple strategic systems that Neil and Jeff have put together allows you to go from 0 to 100 in less time than they did. You get to go through a process of two practitioners who understand the process, the conversation, and really went into detail about it within an incredible course offering. So there's 14 hours of class presentations, 4 hours of Q&A, 50 plus curated resources, and 4 checklists to actually walk you through the steps. How do we conceive of, implement, think of, work through, and monitor these types of erosion controls? When we take a look at this, I would rather just show you what this looks like, because there's so much within the course that it's probably easier to show you everything than it is to do and tell you about it. So, and this is a great conversation for anybody who's just starting off and maybe the course isn't a good fit. If you go on to the Low Tech Erosion Control self-paced course on regenerative living, which I'll put in the chat in a second, and if you start to scroll down the page, one, you'll get a sense of why we're doing this course, why it was important, what's involved in it, how can you go through the process. All of that will be here. But one of the things I love most is Neil and Jeff went through these amazing case studies. And so they went through all these really specific case studies and gave it away for free. So all of you can take a look at this. And I highly recommend you do. This will give you a taste of what you can do in small and large scale conversations. And I've been doing this work for 15 years, and it was incredible the amount that I learned in just the case studies alone, let alone the course itself. It was phenomenal. So I highly recommend take the time, put a note in your calendar, put a little to-do list down and say, I'm going to take the time tomorrow or on the weekend, I'm going to go through these case studies to really see what this can do for my landscape or the landscapes that I work on. And then feel free to take a look at some of the testimonials and why people love the course, because people really love this course. And then I'm going to show you just a quick review of the course. So as you take a look in the back end of the course, we've got 7 phenomenal modules that really walk you through step by step. You'll have the ability to take a look at the session objectives. There'll be the session itself, which is a full presentation from Neil and Jeff, and then in-depth Q&A. The amount of Q&A Jeff and Neil did, they should get an award for it, because they had incredible conversations that they were able to bring to people's attention and actually help guide their conversation. When I say that this is probably the best course of its type, I mean that sincerely. There is no other course that I saw out there that was doing this type of work. And this is one of the reasons why I wanted to bring both Neil and Jeff to the forefront here. All right, so I'm going to just pop back and stop share here for a quick second and bring us all back to the conversation as we have it today. So as we take a look at what Neil and Jeff have presented and what they've done, I also want to take a look at what previous students have said. And people really are effusive with praise for this course because it was incredible. There was so much insight, as Cody said, very insightful course, really awesome stuff. Terry, thank you for sharing so much of your expertise and all experts of your aspects of your work. I'm so happy to have found this course, these strategies, all of you. And when we get into the details of it at the end of the course, I like this first one. This course was everything I could have asked for and more. It really exceeded my expectations. There was so much amazing information and insightful material every session. I can't believe how much they were able to pack in. I'll be digging back into the incredible resources and rewatching these course videos for decades. And this is the thing that I think is the most valuable. Sure, if you've got a book on a subject, you can go back and read it. But if you have actual instructors who are instructing you on the process, you can go back and come to this over and over again. And I see the heat maps on the back end of our learning management system. This is one of the courses people come back to over and over and over again. One person said it was a great course for beginners and practitioners alike. Another was talking about how highly recommended this course is to anyone who wants to do this type of work professionally. I started a business doing stream and wetland restoration, vital information who has access to land, excellent, well-curated course with exceptional facilitators. Resources allow us for deeper study. Appreciate the professional approach and content. Fantastic course to introduce and guide students. This is the way to develop a fundamental understanding and approach of how to erosion control and watershed improvement. It's one thing to try things out, but to have somebody who knows the process, knows the conversation, and goes through their experience step by step to show you just the best of what they've learned, that puts you so much further ahead. So you'll feel comfortable with understanding how and why and when to design and apply low-tech erosion controls. And Neil and Jeff are going to walk you through step by step through the process to design and implement the structures. By the end of the course, this is what people said. They said they felt clear and confident and ready to start their projects. And there's a joy in knowing how to turn eroded dry landscapes into lush landscapes, how to change, as Jeff and Neil showed in the presentation, how to go from the before to the after photos. And as we know, this work is only becoming more valuable. There's only more aspect to this work as we move forward. It's not something that AI can do. This takes people on the ground to be able to observe and understand these types of landscapes. So the course that's normally $249 for the self-paced course, from this moment until this Sunday at midnight, you can get at just $199 using the LTEC 2024 web coupon code. So again, if you're ready to jump in, or if you want to have this as a resource on the shelf, if you just want to buy the book that you know you can always go to, that'll help you with erosion control, this is it. This is the course to take. I can't say it enough because over the time of having been with Jeff and Neil and helping them to offer this course, I know my skills have improved dramatically, and it's just been phenomenal to have both of them be able to offer their conversation to everybody. So again, huge thanks to Neil and Jeff for their conversation, what they brought. It's incredible, gents. I can't say it enough. I know I tell you guys more than a few times, but thank you very much. For anybody that's interested in the course, I'm going to put that into the chat here. So if you want to jump in and take a look, and as folks are saying, done it. And guys, it's so valuable. Yeah, absolutely. So there's a couple of folks who are asking some great questions. And Neil and Jeff, I'm going to start pulling them up, and you guys can decide who wants to take them. So from Melanie, thank you as always for your informative webinars. We're partnering with a group in Malawi. They're working with a local community to regenerate 8 hectares of land. They're in dire condition, choosing money for flour over refreshments at the intro meeting. What 1 or 2 reference books would you help them to 1, grow food, and 2, fixing the landscape for sustainable food production? Interesting question. What do you think? What do you guys think?
I'm going to advocate for Brad Lancaster's 2 books, Rainwater Harvesting for Drylands and Beyond, Volume 1 and 2. Phenomenal books, very user-friendly, lots of different techniques and options, very specific to how to manage water, both for domestic use as well as for use in the landscape and restoring landscapes. The newest versions, make sure you get the newest editions, because he's really improved and revised them over the past several years.
Awesome. Thanks, Neil. Jeff?
I was going to echo that. I was thinking Brad's books too, for everything Neil said, and he does a lot with integrated design and thinking through not just the water, but how do you use that to grow the right plants in the right places, match your water sources up. So yeah, I would also give 2 thumbs up to Brad Lancaster's books.
Awesome. Thanks, Jeff. Folks are putting in the harvestingrainwater.com for Brad Lancaster's. Thanks for that, Jonas. Appreciate that. From Jordan, what is your process for deciding between handwork and bringing in a machine? Great question.
Yeah, I'll take a stab at that. My first range is scale. Like how much material are you working with? How big is the material? How big of an area, and what is access? So I've done some projects where we've brought in many, probably 30 tons of material by hand because there was no option to bring in a machine. And I've done a lot of projects where we use both machines and hand work. So a lot of it's going to depend. So a lot of times it's nice if you have access to a machine. That can be a great way to move materials, rocks or whatever, to where they're needed pretty quickly and easily. And then the hand work comes in to actually use them and build some of the structures. So I think it's a lot of it is what's your scale, what's your access, and then what's your budget? Do you have budget for a machine? Do you have budget for hiring a hand crew, or are you just doing it yourself at your own scale? And so those are kind of some of the driving questions I would be thinking of for a specific project.
Yeah, I echo that. Do you have a lot of people power involved? If there's a lot of people available and they're volunteers, or you're doing a workshop or something like that, that can be a deciding factor. And then what's your skill on the machine? If you're not good with the machine, you can do more damage than good with it. So those are the other things I would consider as well.
Awesome. Thanks, Jens. From Peter, would you consider wood chip mulch or similar as a good idea to help stabilize an eroding track on a steep slope?
I would say it depends. So that would be one where you would really want to think about your flow path and how much water is moving. And so wood chips, they can move. Like I usually don't use them if it's like a concentrated amount of flow. They're really good for maintaining sheet flow, and they're really good, yeah, in those dispersed situations. They can be a great way to slow the flow, protect the soil from raindrop impact, hold some of that moisture around to help get more vegetation going. But if you have clear, like kind of open water flowing, you may want to do something, either a rock mulch, or that's where I like the dirty chips, where I've found mixing the wood chips with mineral earth, and especially if you can layer in some brush or some sort of organic matter that kind of acts in a way like a rebar, that can end up being a lot more robust because you have the different size materials and the different combination of the mineral earth and the brush and the wood chips, that those together can become a lot more stable and withstand a larger amount of flow than a wood chips alone could.
Also, it really depends on what you mean by track. Is it just a footpath? Is it an animal trail? Is it something you need to move a machine on? I try not to use wood chips on tracks where I need to move a machine or a vehicle, because they tend to just hold moisture, and then a lot of times you get stuck. At that point you need to compact the track and do some gravel or other sorts of armoring to have it be a machine travel path. And the other thing I would really be looking at is, how can I get the water off of the track, and where can I get it off of the track so that it can be a benefit and return it to sheet flow in the landscape to support vegetation. Because if the water keeps going on that little path, it's going to be hard to manage in perpetuity, regardless of what you do to stabilize the path. And often you're going to be needing to stabilize the path so much that it's not a great path anymore, with something like rock or things like that. So getting the water off of the path and back out into sheet flow in the landscape would be one of the things I'd be looking at doing as a priority over just treating the path itself. And you may have to do that many times. You may have to divert the water off the path many times.
Awesome, Neil. Thanks, Jeff. Those are great answers. And again, one of the things I like about how both you gentlemen think about is you're thinking at the top of the watershed, where's the flow coming from? How can we mitigate the flow at the beginning instead of just dealing with the symptoms down the track? So I appreciate that. We have our first winner of the Low Tech Erosion Control self-paced course. Pike Nigoma, you have won. Feel free to send me an email, javin@allpointsdesign, and we'll set up your account. Thank you so much for attending the webinar, and I hope it's of value. I'm looking forward to hearing from you about the course. So again, for everybody who's interested, I've just placed the course down there again. And again, Pike, you've won a spot in the course. From Zena, last question. Oh, I see this now. Correct question. A lot of examples seem to be high drylands. Are there any specific techniques for temperate climate? I have a client that's in the West Hills of Multnomah County, experiencing an extreme amount of water. They already have a rock wall and a lot of vegetations.
I mean, it's pretty hard to answer that question. It's pretty broad, but generally, when you get to a humid temperate climate, so a 4-season humid climate, you have the opportunity to use a lot more live vegetation in your erosion control structures and treatments. So things like live willow staking or contour planting the fast-growing vegetation, whether it's willows or if it's warm enough, something maybe like vetiver or some other sort of bunching perennial grass, or even some sorts of trees like alders. Willows and alders are commonly used in erosion control in more humid climates. So I would be using live brush stakes or plantings or things like that, in addition to maybe some rock or other sorts of treatments. But again, it's really hard to say beyond something vague and general like that in a broad situation.
Yeah, that's great. I would echo that. And I'd also be looking at where's the water coming from. And it might be coming from somebody else's property. And that becomes, you have less control over, but might be worth a conversation with upstream neighbors to see if they're interested in doing something to slow the flow and manage that water. And then just reiterating to plan for an overflow. So it's not that we don't need to try to catch and hold every drop of water that comes our way. It's more we want to use it to the best we can within our context and then plan a route for the rest of it to go on somewhere else in a stable and ideally beneficial way.
Awesome, Jeff. Thank you. Thank you both. A great question. And Zena says, amazing. That's perfect advice. Thank you so much. All right, moving on through. Jordan, how often do you dig out for channel features rather than placing features on the surface?
I would say you're almost always going to do some amount of digging because we typically, especially with the rock structures, I should clarify that this is for like one rock dam, Zuni bowls, kind of, we're going to dig in the downstream rocks to create a footer that acts as a splash apron as well as a point of stability. And then the remainder of the structure is typically built on the soils, on the channel surface. There's some nuance and variation to that if you're altering the shape of the channel or to bed things into the banks to get those edges good and integrated. But I'd say as a general rule of thumb, we're digging in the footer splash apron on the downstream edge, probably some amount of digging in the stuff on the sides into the banks a little bit so it's bedded in, and then often the remainder of the structure is on the surface because we're trying to get that lift so that we can catch some sediment, pool some water, and get those benefits in our structure.
The other portion you might be considering digging or doing a little bit of work on is when you're building something like a Zuni bowl or a rock mulch rundown on the upstream edge. You're really going to want to design and build that edge very well so that the water can enter the structure and doesn't just downcut behind or on the upstream side of the structure and undermine it. So you may be doing a little bit of grading there too, so that you match those elevations really well. And a lot of times we'll also be adding some finer materials there, like some gravels, so that the water doesn't just pour into the uphill side of the structure and it really goes up over the structure.
Awesome. Thanks, Neil. Really appreciate that. All right. Next question from Andreas. Can you explain why you use mineral soil with your beaver dams, and does it cause sediment transport?
I think that's referring to the what Jeff calls the upland beaver dams. So they wouldn't actually be they wouldn't be like a beaver dam analog structure that you're building in a channel. So that's what we wrote the brush mineral book on, or manual. And the mineral soil is necessary to really provide plants with the ability to grow in it, to provide the structure to revegetate. And also it is critical for getting the structures to really tie together and stick together well. The fines help the structures stick together well and be stable when they get some flow over them. But generally, these aren't things that are being positioned into a flowing channelized water situation. They're on hillsides or in sheet flow situations. So that those are things to keep in mind. And there always will be some sediment transport. But if you're slowing and soaking down water, you're going to be dropping out more sediment than is moving on. Commonly.
Jeff, did you have anything you wanted to add to that?
I think that was a great overview. I think that is like the context is key. And I think that the bedding aspect of the mineral earth, it helps to bind together. And I saw somebody just posted in the comments that it also does make it so if you're using a bunch of brush or organic material, that mineral soil neutralizes potential fire risk and just really helps to up the moisture holding capacity of these structures.
And remember, one of the anatomy points is filling space. So the mineral soil is the finest material, so it fills the space really well, so that it minimizes the big air pockets in any of these structures.
Brilliant. Thanks, gents. And we already have a few people who are signing up for the course. Great to see. From Jordan Sanders, how far out are you guys booked, and how far do you travel?
I at least am penciled in for the rest of the year. I'm waiting on, it's always contracts and negotiations and that sort of thing to finalize things. So yeah, a lot of these projects take a good amount of advanced coordination with clients and other partners. So it's nice to have ample lead time. As far as how far do I travel, currently most of my projects are within 3 or 4 hours of Moab, but open to other things. That's just I've been able to keep busy enough in the region here.
Yeah, right now I'm booked out until October. And I'm not doing much traveling. I have 2 toddlers. So I'm doing more fatherhood stuff with a focus on staying closer to home these days. But that, may change in the next few years.
Awesome. Jeff, I'll just get you to mute when you're not chatting, if that's okay. It looks like we got a little bit of feedback coming in. Thanks, man. Raphael, how would you adapt these methods of retaining water in humid climates where floods are more the problem than drought? I feel like you guys kind of answered that before. Is there anything you wanted to add to that question?
I mean, the common flood control structure is going to be something like a pond in a humid landscape. Can you store larger quantities of water in the uplands and not allow it to flow as quickly down through the different water flow paths and to create floods? So slowing the movement of water through the landscape, also improving soils. I mean, that it's really the fundamental piece, like I shared with just getting soil cover on bare ground. Improving the water infiltration and retention on soils by improving soil health through proper plant management and livestock rotation and that sort of situation is really critical. And I mean, finally, the question becomes, where are the floods coming from? Often it's through, impervious surfaces, that we've developed roads and buildings and other sorts of infrastructure. And so if you're able to also integrate things like, water tanks, cisterns for storage, smaller features that are storing water in the landscape and slowing the runoff from those, impervious surfaces, those things help mitigate flooding. But when you start to talk about, larger scale floods, you're looking at landscape scale approaches. So, one little thing doesn't work. You really have to look at all the different strategies and adding them together into these, large treatment drains to achieve an effect.
Sounds good. Thanks so much, Neil. From Neil, from Leo. It's the other one. From Leo, can you expand about tips up, tips down, and why you would use the one and not the other? Example, I would have thought that the top of the watershed would be going slow enough to want to catch tips up rather than shed tips down.
I'll give a quick answer and then see if Jeff has some filler or broader explanations. Tips up means that you're matching the shape of the land. So one of the pieces that's important in this is to fit the form of the structure to the land and the situation that you're in. So tips up is when a contour is shaped like a ridge. So alluvial fans are commonly locations where you would use a tips up media luna, because really what a tips up media luna is it's the basic building block of an alluvial fan. It creates a spreading feature that spreads out sediment and water to create an alluvial fan. So when you're in that place in the landscape, the toe of the slope, the alluvial fan, is where you commonly use a tips up media luna. A tips down media luna allows the transition from water flowing as a sheet flow to water flowing as a channelized water flow. And what it does is, so that you're in a valley, you're in a place where you're coming out of a flat area and transitioning to a steeper portion in the landscape. And so it matches that shape of the contour of the valley. And what it does is it slows down the movement of water from sheet flow into channelized flow, and it stores some of that water and sediment on the uphill side of the tips down media luna, and it stabilizes the transition. Often you have something like a head cut forming there or a rill. It stabilizes that transition into the channelized flow. So it slows and pacifies that transition to allow the water to move into channelized flow, which it has to do naturally to go from somewhere like the top of the hill into the transport zone where it's steep. It can't stay a sheet flow on a steep slope like that. So you're just stabilizing and slowing that transition to allow the water to be a little bit more passive and less erosive.
Jeff, anything to add?
I think that was great. Yeah, I think it's a lot is your land position and whether you're trying to concentrate the water into a naturally generally steeper zone or whether you have an opportunity to spread it out over a wider area. So don't get caught on, in the graphic it shows the tips down at the top of the watershed, but if you're in a broader valley at the top of a watershed where you can spread the flow, then that would also be an appropriate spot for a tips up spreading version of the media luna.
Fantastic. Thanks, Jeff. So a couple of praises coming in. Awesome.
Awesome.
Sorry about that, Jeff. Maybe you could mute me through you. From Pike, learning a lot. This will help us restore our landscape. Seeking running water has been a major challenge. From Nadia, as a feedback, I've taken the course before and learned so much from it. We mainly use logs that we have in our forest to build small dams and slow down water in hillsides. Also use cottonwood stakes to build terraces to slow down water. That's fantastic. So it looks like we've got some folks who've taken the course before. Fantastic. Also, we've got our second winner. So Sabine Gwen, you've won a spot in the Low Tech Erosion Control. Fantastic. Thanks so much, Sabine, for being on the call today. And feel free to email me to claim your spot. All right, gents, we just have a few more minutes here, so I'm going to pick and choose a few questions here. One is from Melanie. What about remote consultations? Are you available to give advice from Google Earth images?
Yeah, I do a lot of remote consultation.
And Jeff?
I have not done as much remote. I mean, I read Google Images all the time, but currently most of my projects are kind of embedded as design builds. So I would recommend Neil for that. And if there's something that specifically needs me to plug in, I'd be open to that conversation.
Awesome. Thanks, Jeff. From Daniel Helsley. Hey, Dan, nice to have you here. Since many of the ravines are incised, how do you build back the ancient floodplain and large basins for better infiltration?
I'll take this one to start. Jeff, maybe you can follow. So when you're working in an incised gully, right? You're now working in something that is modeling the stream evolution process. And so the way that works is first you have to achieve vertical stability. Well, let's back up. You probably will use something like induced meandering. So it's a more complex process that Bill Zedek developed and has this whole book on it. So you need to stabilize the vertical movement first, which is basically making sure there's no more head cuts or incisions moving up through the ravine. Once you achieve vertical stability, then you get horizontal instability. And what happens there is that the water starts moving from side to side. You're getting some point bar formation. You can use techniques like baffles to accelerate that. And the water is chewing into the side banks of the ravine and the gully. So it's horizontally unstable. It's widening the gully, and that deposits a bunch of sediment down into the gully that the water is then able to chew through. It slows down and reduces the stream power. And that sediment is what rebuilds the point bars and floodplains inside of the incised gully. So now you have a new floodplain and stream channel system that is lower down in the landscape in the incised gully. And over time, that has the potential, depending on the situation in the gully, to move to a grade enough to move back up and access the historic floodplains, but that's less common. And then if you're in a smaller gully situation, you could use a technique like a plug and pond or a plug and spread, where you plug the gully and divert the water out into sheet flow in the historic floodplain. And that technique can be very effective, but you also have to be very attentive to where that return flow is going back down into the gully and making sure you plan for and stabilize that, or you just get a new gully forming from your return flow over time.
Thanks, Neil. Jeff, anything to add?
Yeah, I think that is great. That kind of channel evolution process and widening the incised gully to get that inset floodplain is a key thing. I've also seen and worked on projects where sometimes if you're not able to do that, incremental lifts, like doing a one rock dam that say catches 6 to 12 inches of soil, and then you build another one, and you incrementally bring that channel back up to a grade where a certain stage flow event can reconnect with that historic floodplain and or rehydrate the root zone of the plants on it. And so that I think that can be another technique in certain instances that can be appropriate.
Fantastic. Thanks, Jeff. Appreciate that. Well, folks, as we come to the last final minutes here of the, oh, sorry, Neil looks like he had his something to add. Go for it.
I did. Just one other thing that people have done that's been very effective in that sort of situation, if you have the tools and the skills to do it, is what I've heard termed basically livestock bulldozers. And so that's using ultra high density grazing to lay back the banks of the streams to a situation that widens the gully and allows vegetation to reestablish on the gentler slopes on the banks. But you have to both have the livestock and the skills of doing ultra high density grazing to do that effectively.
Awesome. Awesome. Thank you, Neil. Thank you, Jeff. Thank you, everyone, for participating. We really appreciate it. Our final winner for the Low Tech Erosion Control self-paced course is Tara Lakshman. I'm going to go with that. And you can tell me I'm wrong later on. As usual, please do send me an email and we will make sure that you get yourself into the course. For everybody else, if you're keen on the course will have a discount code applied to it until Sunday evening at midnight. There is no extension. So it'd be a pleasure to see more folks in that course. And we will be taking a look at potentially running a live version next year, but it's absolutely not a guarantee. And what else do I have to say? Jeff and Neil, thank you so much for the work you guys do. Thanks so much for being able to lay it out so clearly and so precisely. Neil, thank you for your always exceptional answers. Jeff, thank you for your always exceptional answers. And lots of appreciation coming in. Malawi appreciates a lot. Thank you from Zena. Awesome. Thank you all. This was great from Tara, from Katya. Thank you so much. Great information. Cheers, fellas. Thanks to you all. Awesome. Thank you, everyone. And thank you, gents. Final words from you guys. What's the bumper sticker you want to leave people with?
Don't be afraid to get out there and try something. Get out there and play with the water and play with the rocks and vegetation and other things that you have available, and start in areas of landscape that are already pretty good and with low risk, high return opportunities, and learn from them and build your skills over time.
Yeah, absolutely. What Neil said, have fun with it, and try new things, like really key in on the patterns and the processes, and then be creative, because I think there's a lot more ways to work with the land and with the water in a beneficial way. And I know I'm always learning through innovation and through seeing other people's innovations and adaptations. So yeah, get out there and play.
Awesome. Thanks, gents. Jordan's add to it and get your kids involved. And I'm sure the two of you guys do. Thanks, everybody. Again, my name is Jav Bernakovich with regenerativeliving.online. If you're looking for practical skills to live on the planet as if we intend to stay, check out the previous self-paced courses. We have some amazing courses coming up this year, including an incredible biogas digester course, as well as revillaging the city with Mark Lakeman. So hopefully we'll see you in those. If you haven't signed up for the newsletter yet, please do on there, or just sign up for a free account. There is some free resources there, and you'll be entered into the newsletter all the same. Thanks so much, everybody. Hopefully we'll see you in the class, or we'll see you next time. Take care.